All right, it's finally time to tackle our final project, the Caesar Cipher. As I've mentioned before, Caesar Cipher is this way of encoding text that was seen as early as during the times of Julius Caesar. So when he had these top secret military messages, what he would do is he would shift each letter of the alphabet by a certain predetermined amount. I want to show you quickly how this works. So we've got the alphabet here, and let's say we wanted to encode the letter E. So now we can line up the alphabet with a new set of alphabet, and at the moment the shift is 0 because the top alphabet and the bottom alphabet are lined up with a 0 difference. Now, let's say that we had a shift of 1. Well, then the alphabet moves to the left and A becomes B, B becomes C, etc. And we can keep going until we get to the amount of shift that we wanted. So let's say we're going to encode all of our text with the shift of 3. Well, then E becomes H, F becomes I, G becomes J, etc. And so on and so forth. And they've actually discovered these artifacts from ages ago where people have created these sort of dials. And by simply rotating the dial to a certain amount of shift, then you can line up the letters with each other. So A becomes N and Z becomes O, and so on and so forth. And this is a way that people actually encoded top secret messages. By the end of this day, you will have also built a digital form of the Caesar cipher. And all you have to do is to type encode to start encoding a message. Let's say something like, "Hello world." And once we hit enter, we get to type the shift number, which I'm just going to choose a random one, and it gives us the encoded result. So now if I take this encoded result and I go ahead and type yes to restart my program, and I'm going to use the decode function to decode my message. Now, when I use the same shift number, then I should be able to get back the decoded result. So if there's people monitoring your phone, or you're trying to throw a message to your friend in a paper ball, then this is an easy way to ensure that if your message was intercepted, then it won't be understood by the other person. Once you're ready, let's get started by heading over to replit/@appbury/CaesarCipher1 start. And this contains the starting code for this project, and this is part 1 of 4. So here I've already saved you the laborious task of typing out all the letters in the alphabet, and they're stored in a single list. Now I've also got 3 inputs. So this is what the user is going to type in. They're going to type in encode or decode, and that's going to be saved to the direction. They're going to type their message, which is going to be changed to lowercase, and this is going to be saved in text. And finally, they're going to input a shift number, which is going to be converted to an integer and saved inside this variable called shift. So if you want to, have a run of the program as it is right now so that you fully understand what's actually going on before you get started. And remember, don't change any of the code above, but instead tackle the to-dos one by one. The first step is to create a function called encrypt that's going to take this text that the user typed in and the shift that they typed in as inputs. And this is going to use what you learned about functions with inputs from today's lessons. And then once you're done with that, step 2 is to go inside the encrypt function that you just created and shift each letter of the text forwards by the shift amount. So again, as we saw before, a shift of 1, a shift of 2, a shift of 3 basically just moves the characters forwards so that each letter of the alphabet becomes a letter of the alphabet much further down the line. And let's say that the user entered the text hello, and if we tried a shift of 5, then the end result should be MJQQT, and the printed output from this function should say something like the encoded text is this. And finally, you're going to call the encrypt function and then pass in the user inputs from over here, and you should be able to test the code and encrypt a message and see something like this happen. Pause the video now, have a look through the starting code, and once you're ready, go ahead and tackle it, and then come back and we'll go through the solution together. Good luck. All right, so I'm going to fork a copy of the starting file and tackle to do number 1, which is to create a function, which is done using def, and it's called encrypt. And this function is going to take 2 inputs. So inside the parentheses, I'm going to put 2 parameters. Now, you can, of course, use the same word as the inputs that you're going to put into it, but in an ideal world, you try to not confuse yourself between the arguments and the parameters. So I'm going to call this plain text, this first parameter, and the second parameter, I'm going to call it shift amount. Now, of course, at a later date, when we're sending the input to this function, we're going to be sending the text to plain text and shift to shift amount. But keeping the names of the argument and the parameter different will help us later on to see which one is which. The next step is to go inside the encrypt function, which of course means indenting by 1. We're going to shift each letter of the text forwards in the alphabet by the shift amount and then print the encrypted text. This is going to be the challenging part of this whole exercise. But essentially, if we think about the problem, what we want to do is we want to take each letter in the plain text. So let's say our plain text is equal to hello. Then we're going to take each of these letters in turn and then shift it up in the alphabet by the shift amount. So let's say, for example, our shift amount was 5 and our plain text was hello. The first thing we're going to do is we're going to take the H, which is over here, and then we're going to shift it up by 5. So 1, 2, 3, 4, 5. And we're going to turn it into an M. We can start off by writing a for loop that loops through each of the letters in the plain text input. And then we can take each of these letters and work out its position in the alphabet list here. And we can do that by using the index method. So we can tap into a list, write .index, and then put in the value that we want to get the index for, and we should be able to get that as the result. So back over here, we're going to say alphabet is the list .index, and then inside the parentheses, we can put in our letter. So we want to find out the index of the letter that we're looping through in this alphabet up here. And once we've gotten a hold of that, we're going to save it into a variable called position. Now, once we've got that, then we're going to calculate the new position. Now, the new position is just going to be the previous position, which is going to be a number, and then plus the shift amount. So while we're going through this code, let's look at this word H. So the first time the loop runs, letter is going to be equal to H. Position is going to be equal to 0, 1, 2, 3, 4, 5, 6, 7. And then the shift amount is 5. So 7 plus 5 is going to be 12. So now the new position is going to be 12. And we can tap into the alphabet list at position 12. So 7, 8, 9, 10, 11, 12, and get hold of the value at that position. So we can say that new letter is equal to the alphabet at the new position. And now, once we've got this new letter, we can create an empty string here, which we'll call the cipher text, which is going to be the encoded text. And it starts out being an empty string. And then once we've gotten each of the new letters, we're going to add it to the cipher text. Now, the final thing we have to do inside this encrypt function is once the for loop has run its course and we've added all of the new letters into the cipher text, then at this point, it's a good idea to print out the output. And it tells us that we should say something like this, where we replace this final thing with the actual encoded text, which is of course called a cipher text in our case. Now let's just make that into an F string so that it'll insert it when it runs, and we're ready to tackle the last to do. So here we're going to call the encrypt function, and we're going to pass in all of the user inputs. So remember that our parameter names are plain text and shift amount. So I'm actually going to use the keyword arguments. So I'm going to say plain text is equal to the text that the user has typed in. And then on the next argument, I'm going to say the shift amount is equal to the shift that the user has typed in. So now we're ready to test our code, and let's take a look at what happens. So I'm going to use this example that we've done here by trying to encode hello with a shift of 5. Now, the first thing that we type, the direction, doesn't actually matter because it's not being used anywhere in our code, at least not yet. So you can type anything you want. I'm just going to type in code, and then the message is going to be hello, and the shift number is going to be 5. And now it tells us that the encoded text is MJQQT, which matches with the expected output. You might think that we're done, right? This is perfect, this is great, and we've completed this entire exercise. But let's consider a different scenario. What happens if we tried to encode a word that had letters that were really close to the end of the alphabet? Let's say that we wanted to encode the message Zulu. Now, I'm only doing that because there's a Z in that word, of course, and we wanted to shift it by 5. Now, let's think what's going to happen, right? In our code, we're going to take each of the letters. We're going to take Z first, and then we're going to get its position in the alphabet and add the shift amount to the position to get the new position. Now, this is already at the end of the alphabet. So if this number, which is going to be 25, because there's 26 letters in the alphabet, and we start the position at 0. So this plus 5 is going to be 30. And what happens when we try to get the 30th item from the alphabet? Well, you'll find out when I hit enter. We get an index error, and it tells us that list index out of range, and it occurred on line 15. So just as we predicted, this does not exist. We have to try and tackle this, right? So if you haven't thought about this, this is the time to think about how can you solve this problem. I want you to pause for a moment and try to see if you can fix it. All right, so we know that this has a fixed length. And what we want to happen when we have a letter towards the end that we need to encode is to loop back to the beginning of the alphabet. So to solve this, all we have to do is just to copy the existing letters in the alphabet and then just duplicate it once more. So this means that if we find a letter that's Z and it needs to be shifted up by 5 letters, it's going to continue until it gets to E. Now, the really wonderful thing about this index function is it's going to give you the first index that it finds. So if we're looking for the letter A, it's going to give you the index 0, and then it's going to stop. It's not going to look for all the indices and find this one at position 26. So it means that our code will now work even if we have a word that have a lot of letters towards the end of the alphabet. Let's go ahead and give it a spin. Let's type in code, and our message is again Zulu. And we hit enter, and then we have a shift number of 5, and we get our encoded text. Z becomes 1, 2, 3, 4, 5, it becomes E, and U, 1, 2, 3, 4, 5, becomes Z. So now we've solved that small bug. Now, there's a lot of other ways that you could have solved this bug, but I think this is the easiest way without disturbing our logic here and not making our function even longer. If you had any problems with your code, then this is the time to go back and fix it. And make sure that you really understand everything that's going on here before you move on to the next lesson. But once you're ready, I'll see you on the next lesson where we're going to decrypt our code.